and one of the finest of its kind in India. And very recently this is launched, and I am your chemistry teacher. I have been mentoring and guiding the students preparing for JEE Main, JEE Advanced and Neet exam as well as plus 2 board exams. Now, this is yet another class on molality, and actually this is the second class on molality. In the last class of molality, we have discussed that basic definition of molality and the effect of temperature on molality, and the relationship between molality and molarity today we are going to discuss. And in fact, uh, the definition of molality, what you know, that is nothing but the number of moles of solute present in 1 kg of solvent or 1000 gram of solvent, correct? Similarly, what is molarity? Molarity simply represents the number of moles of solute present in 1000 ml or 1 liter of solution. So here you see both the units, molality as well as molarity, both the units are meant for what? Meant for expressing the strength of solution or concentration of solution, correct? Now, here you see the relationship between these two, and this is the basic definition already we have discussed in the last class. This is for molality, and you know that molality, this is one of the important unit so far as that strength of solution is concerned, because you know it has many applications in that solution chapter in determining different qualitative properties of the solution. Already we have discussed in the last class, correct? And it is independent of temperature, and it doesn't depend on temperature as well as pressure. But you know that molarity quantity depends on what? Depends on temperature, because in the expression of molarity, that volume term exists, because in the definition itself for the molarity, what we say, it is the number of moles of solute present in 1000 ml of solution or 1 liter of solution. So that volume quantity is there, that is 1000 ml or 1 liter, that simply represents volume of the solution. So that volume term is there in that expression of molarity. That's why that molarity is dependent on temperature, correct? So today I am going to discuss that relationship between molarity and molality, correct? So that relationship is mentioned here, but here I am going to derive that. So let's consider that molarity of the solution, let it be X. Let the molarity of solution equal to M, or you can consider that is X moles per liter. So let the molarity of solution equal to X moles per liter, and density of solution is d gram per ml. Now, taking the help of these two, we can derive that expression for molality, correct? How? You see that molarity X moles per liter, what does it mean? It means X moles of solute is present in 1 liter of solution or 1000 ml of solution. 1 liter of solution or 1000 ml of solution, correct? So this is simply X moles of solute in 1000 ml of solution, because 1 liter is equal to 1000 ml. That's why we can consider X moles of solute present in 1 liter or X moles of solute present in 1000 ml of solution, correct? Now here you see density of the solution we have taken as d gram per ml. So what does it mean? It means 1 ml of solution has what mass? D gram. So the mass of 1 ml of solution is d gram, correct? Now what is the mass of 1000 ml of solution? So mass of 1000 ml, mass of 1000 ml of solution is equal to what? 1000 into D gram. So now this is the mass of the solution, correct? Now, out of this much mass of solution, we can easily find out the mass of solvent. How? So mass of solvent. Mass of solvent. So mass of solvent in which unit? In gram unit. What is that? This is the mass of solution. Simply mass of solution in gram minus mass of solute in gram. Correct? So out of solution mass in gram, if you subtract that solute mass in gram unit, then you will get the mass of solvent in gram unit. Correct? Now you see, what is that mass of solution in gram unit? That is here. Because you see that mass of 1000 ml of solution is 1000 into D, that this much gram. So this is 1000 D, this much gram minus, what is that mass of solute in gram? You see that molarity of the solution we have taken as x moles of x moles per liter. That means there is presence of x moles of solute. If we consider molar mass of solute, if we consider molar mass of solute as y gram, then tell me what is that mass of the solute? That will be x into y, because molar mass of solute, if you take y gram, then that x mole, molar mass of solute means mass of 1 mole of solute. Mass of 1 mole of solute. If the mass of 1 mole of solute is y gram, then mass of x moles of solute will be what? X into y. So here you see, here we can consider x into y, this much gram. This is the mass of y x moles of solute. This is the mass of x moles of solute. So here we can consider where that y is equal to molar mass of solute in gram. So here we are assuming that molar mass of solute in gram is y, which is the molar mass of solute in gram unit. So this is the mass of solute in gram, this is the mass of solution in gram. Then subtracting that mass of solute out of that mass of solution in gram, we are getting this mass of solvent in gram. Correct? Then what is that expression for molality? What is that expression for molality? Basic formula of molality. Already we have discussed that in the last class. So that molality expression is number of moles of solute by mass of solvent in kg. Correct? If the solvent mass is not in kg, then in that case we consider what? If it is in gram. If the solvent mass is not in kg, if it is in gram, then the expression is something different. What is that? That is number of moles of solute divided by this is, here I am in. So you see, this is equal to so this is equal to this is, again here I am writing that molarity is equal to number of moles of solute by 1000 into this is into, so here you see, so this is number of moles of solute. Here we have taken that number of moles of solute. So instead of this solvent mass in kg, if it is in gram, then what is that expression? That expression is this one, 1000 by W solvent in gram. correct? So this is, I think, yes. So number of moles of solute into 1000 by W solvent in gram. Here you see again, here again. Now the point is why that 1000 comes. Why that 1000 comes? Because here in the main expression for molality, that formula of molality, we are considering this mass of solvent in kg. Suppose the solvent mass is given in gram. Solvent mass is given in gram. Then we'll have to convert that solvent mass in kg. Then you know that if 1 gram, if you consider, that is equal to what? How much in kg? That is nothing but what? 1 by 1000 kg. Correct? So if the mass of solvent is in gram, then how can you convert that to kg? Very easy. W gram of solvent. Correct? So W gram of solvent is equal to what mass in kg? That is W by 1000 kg. Correct? Because you know that 1 gram is equal to 1 by 1000 kg. Correct? Very simple. So W gram of solvent is equal to W by 1000 kg. Therefore, if the mass of solvent is given in gram, then easily you can convert that mass to kg by using this expression. W gram of solvent is equal to W by 1000 kg. Correct? So using this, we can easily derive this expression. Here you see, I am deriving that. Here you see, I am deriving that. Very easy. So you see, suppose mass of solvent is equal to W gram. Correct? Then how much it is in kg? That is W by 1000 kg. Correct? Then what is that expression for molality? Molality is equal to what? Number of moles of solute. Moles of solute by mass of solvent in kg. Now you see W gram of solvent in kg is equal to what? That is W by 1000 kg. Correct? Now you see, so this is number of moles of solute into what? Into 1000 by W. What is this W? W gram is nothing but the mass of solvent. So this is nothing but mass of solvent in gram. So here we can consider this is your W mass of solvent. That is, so this is your 1000 by mass of solvent in gram. Correct? So here it is 1000 by W. Correct? This W by 1000 becomes 1000 by W. So that W is nothing but what? That W is nothing but mass of solvent in gram. So this is mass of solvent in gram. So number of moles of solute multiplied with 1000 by mass of solvent in gram represents molality. And this expression is valid whenever we consider solvent mass is in gram unit. Correct? And if it is in kg unit, then simply we use this expression number of moles of solute by W, which is the mass of solvent in kg. There this quantity 1000 doesn't count. Correct? Now, what is the relationship between these two? What is the relationship between these two, molality and molarity? Very simple. So in that relationship, we already discussed one thing. If you consider, you see, so you see already, yes, in this here already we have derived one part of that relationship. If we consider that molarity of the solution is x moles per liter, then it means x moles of solute in 1000 ml of solution. Density we have taken as d gram per ml. Then what is that mass of that 1000 ml of solution? 1000 into d. Then mass of solvent in gram is coming what? Mass of solution in gram minus mass of solute in gram. Then this is your mass of solution 1000 d gram, and this is xy gram. What is that xy? Here x is the number of moles of solute. Correct? Y is the molar mass of solute in gram. Then this is the mass of solution in gram minus mass of solute, that is xy gram. And here you see this result gives you the mass of solvent in gram. Now, if the solvent mass is in gram, Then what is that expression for molality? Just now we discussed that that expression is this one. You see, just now we discussed that expression is this one. You see, this one, number of moles of solute into 1000 by mass of solvent in gram. Now you see this one. Here we can consider that number of moles of solute is what? X. Why? Because we have assumed that molarity of solution as X moles per liter. Correct? We have taken that molarity of solution as X. That means molarity of solution is X, means that X moles of solute is there in 1 liter of solution. So here that number of moles of solute in that 1 liter or 1000 ml of solution is X. Correct? Into 1000 by, what is that mass of solvent in gram? That mass of solvent, just now we discussed that mass of solvent in that 1000 ml of solution or 1 liter of solution having molarity X. Correct? What is that mass of solvent? Just now we proved that, we calculated that, that is 1000 D. That is 1000 D minus X into Y. So 1000 D is the mass of solution minus this is the mass of solute. This result gives you the mass of solvent in gram. Now this expression represents what? Represents that molality. So you see this expression represents that molality. So finally what we are getting here? So you see molality is equal to X into 1000 divided by 1000 D minus XY. We can simplify this further. How? If you consider this molality in short can be written as small m, correct? That implies small m, molality small m is coming 1000x. So what is this x, my dear? What is this x? X is nothing but that molarity. At the beginning we have taken that molarity of the solution as x, correct? So in place of this x we can consider this is the molarity of the solution. This is molarity, correct? This is molarity. Molarity divided by, so this is 1000 D minus, what is this x? This is molarity of solution, correct? Into, what is this y? Y represents the molar mass of solute. This is molar mass of solute. Mass of solute. So you see, this is the relationship between molality and molarity. This can be further simplified. How? Simply, if you take the reciprocal of this molality, then it becomes what? Then it becomes 1 by molality. Reciprocal of this molality, if you are taking here, then it becomes 1 by molality, becomes equal to what? 1000 D minus, this is molarity, this is molarity, correct? And this is molality. In fact, this 1 by m means this m is molality, correct? So you can consider this one as 1 by molality is equal to 1000 into D minus molarity into molar mass of solute. Mass of solute upon 1000 into molarity. Now this one 1000 D by this by this minus this by this. So if you consider the 1000 D by this, then 1000 will be cancelled. So this becomes density of solution. This D is nothing but density of solution by molarity minus this is this molarity into molar mass of solute by 1000 into molarity. So this by this, then molarity will be cancelled. So this becomes molar mass of solute by 1000. So this becomes molar mass of solute, molarity cancelled by 1000. So finally we got the expression, that is 1 by molality is coming density of solution by molarity. So this is the relationship. 1 by molality is equal to density of solution by molarity minus molar mass of solute by 1000. So you see, using that density data given in the question in gram per ml, density data given in question in gram per ml, correct, and molar mass of solute in gram, directly we can calculate the molality of the solution. And here molarity must be given in moles per molarity. As you know that molarity unit is moles per liter, so always you will find that molarity data will be given in moles per liter, but the confusion arises that density unit may be given in gram per ml or may be given in kg per liter, correct, and the molar mass of solute may be given in gram or may be given in kg. So if it will be given in kg, then this expression will be changed. This 1000 term, this quantity 1000 will not come in that expression if we consider that molar mass of solute in kg, correct. And what will be that expression of involving that molality and molarity, taking the density into account if the molar mass of solute is in kg. That you all try. In the next class I will discuss. In fact, one hint I want to share with you, that this 1000 term will not come, correct. Now here this is one important expression. Using this expression we can calculate molality. If density is given, molarity is given, molar mass of solute is known to us, or molarity may be asked, molality, density of the solution will be given, and molar mass of solute is known to us, correct. And using this expression we can also establish relationship between molality and molarity, and under which condition molarity will be equal to molality, molality will be greater than molarity, molality will be less than molarity, correct. So those things we'll discuss in the next class. And here that is one important there is one important case where we know that molality becomes equal to molarity, correct. That is one important expression and one important case, and that case can be derived from this expression, correct. That we will discuss in the next class. And I hope all of you got this concept of how to establish the relationship between molality and molarity. And in the next class we'll discuss some more important concepts, interesting concepts between molality and molarity. What are the other relationship, or you can say under which condition that molality and molarity will be different, molality and molarity will be equal, and molality will be greater than molality or less than molarity. Those things we'll discuss in the next class. And out of 1 mole and 1 molar solution, which one is more concentrated, that also we'll discuss in the next class. I hope all of you got the concepts what I discussed in today's lecture. And with this I want to end my today's lecture. Yes, good news students, those who are preparing for the JEE Main Session 2 and Neet to 2024. Very soon we are going to launch our test series, and at a very minimal cost of 199 for the test package, and you can easily access that text just by visiting our website, and that website detail given in description box, and there you can get every detail and more details about that test series. Thank you all.